Alright, welcome back. This is going to be our second video on mathematical induction. I'm just going to abbreviate that here as mathematical induction like that. So this is going to be video number 2. Okay, so in the last video we gave an analogy using dominoes, and we're going to, instead of using an analogy now, we're going to actually talk about the kind of induction that we're going to talk about how we can use mathematical induction, not just an analogy of using dominoes, but how we're actually going to use it in our system of, in the case of sentential logic. So before we had dominoes, and we were going to try to reason over an infinite line of dominoes. In this case, the things that we're going to be reasoning about are sentences in SL. So rather than dominoes, we're now going to be talking about sentences of SL. And one of the one really important point here is you'll notice when in the case of the dominoes, what we had was an actual infinite sequence of them, right? So, well, remember we had a starting point, and then this sort of went on forever. And the whole reason why our reasoning worked, right? We said, look, there's some property that the first domino has, and we said then, look, for any arbitrary domino in this series, right? Suppose it's k, whatever. If we get to k, we can show that k plus 1 also has that property, right? And so we use the falling down property as an example. Notice that these dominoes are put into a sequence. So our reasoning wouldn't work if we had a whole sequence of dominoes like that, but then we had one sort of lone domino over here on the side. Then our reasoning wouldn't work, right? I couldn't say, hey, look, I have my base case, right? So I say if the first domino falls down, so we'll do this as my base. If I say, look, what we want to show is like all the dominoes will fall down. And I can argue that, you know, by pressing this first one, the first one will press down, and then I argue for any k, right? So if I say if k falls down, then k plus 1 will fall down. This is k plus 1. And remember, we called this the inductive step. We suggested that these two, providing an argument for why the base case has the property and arguing for why the inductive step has the property, is sufficient to say that all of the dominoes have that property. But that won't work if I have this domino over here on the side that's not a member of the sequence, right? So mathematical induction basically allows you to say something about an infinite number of cases as long as all of those cases are in the appropriate sequence. It won't work if you have this lone domino over here. In other words, what you need is a series. So you need to be able to line up all of your cases for mathematical induction to work. This is extremely important. If we don't have this series or the sequence of cases, even if it's infinitely long, if you don't have the sequence, mathematical induction is no good. So it won't work for these cases. So that said, we need to figure out how do we build, or do the sentences of SL, do they make up a series? And if so, how does that work? Well, the answer is yes. The sentences of SL, you can think about putting them all into a series, and you can do that in the following way. Recall that our definition of sentences of SL worked like this. We had, actually let me just pull it over here rather than having to write this all out. So remember, we had this definition, this was a recursive definition of sentences of SL, right? We said every sentence letter, where a sentence letter is any Roman letter, we said that every sentence letter is a sentence. And then we said, look, here's how to build up new sentences recursively. So give me some sentence. Then putting a negation sign in front of it will build me a new sentence. Alternatively, you could give me two sentences, right, of any size, right? They don't have to be atomic sentences, they can be complex sentences, but give me any two things that are already sentences, then it can build you a new sentence by adding the conjunction. Or I could do it with disjunction, or I could do it with the conditional, or I can do it with the biconditional. And then we have, as a sort of last step, we said, look, nothing is a sentence unless you can build it up from these two. So imagine that we had, our language was really, really simple, right? Imagine that the only sentences we had were A and B. So imagine these are the only kinds of sentences that we have in our language. Now, strictly speaking, we have an infinite number of these, but just for demonstration, I'm going to point out, I'm just going to assume that we only have two sentences. So given our definition, then, we see that A is a sentence, and we also know then that B is a sentence, right? Given the definition that we had before, right? By one, we said every sentence letter is a sentence. Our sentence letters are A and B, then we know that A is a sentence and B is a sentence. And we also know that, that not B is a sentence. We also know that not A is a sentence. Again, by number 2 here, right? So we said that adding a negation sign is a sentence. And we can go through and we can construct all the sentences using the ones that we have before. So we have this as sort of step 1 in our construction of our language, right? These are the first two sentences we get. Now we're going to do an application of each of these rules to the previous set of sentences that we've built so far. So you can think of this as being like stage 1. We're going to use all the sentences we have in stage 1 and use all of these rules 2 through 6 to build our next stage of sentences. So we've used negation on both of these two sentences in here, but that's not all. We can also use conjunction. So we can get A, and B will also be a sentence by rule number 2. And so will A or B. And so will A, if A, then B. And in fact, actually, we can also change the order in here as well. So if B and A will be another sentence. B or A will be another sentence. If B, then A will be another sentence. A if and only if B, and B if and only if A. Okay, so this you can think of as being stage 2, right? This, we used stage 1 as our input, and we built up all the sentences we could using just from the sentences from stage 1, using 2 through 6, right? So these are you can think about them as our construction recipes of how to build sentences. So at stage 2 now, we have all of these sentences plus all the sentences from stage 1. Stage 3, and this is where it will sort of start getting a little bit big, and I won't write them all out, but you can think about stage 3 as using all of these, using all the sentences from stage 2 and using rules 2 through 6 again to build a next set of sentences. And from stage 1. So just to give you an example now, we can have A and not B, A and not A and not, A and, that's not what I wanted to write. A and B. I'll just do this. So you can see what I'm doing is I'm picking A, and then I'm using conjunction to build all these new sentences using all the other sentences that I have. So I'm combining A and, oh, I actually already have A and B in here, so that'll be duplicating things, but that's okay. We just want to make sure that we cover every possible sentence. But you can see that what I'm doing here is using the conjunction rule to combine A with each of these sentences. And then I would be doing the same thing with B, right? I would use B and then use conjunction to add them to all these sentences. And then I would use not B, right? So at some point on this list, I'll use not B, and I'll do and then I'll join it with each of these sentences as well. So I'll have not B and A, and then I'll have not B and B, and then I'll have not B and, eventually on the list I'll get to A and B. And then once I've done that for all of the conjunction, then I'll also do it for disjunction, and I'll also do it for the conditional, and then I'll also do it for the biconditional, and I actually almost forgot, I'll also do it for negation, right? So the first thing I'll do with negation is do not A, and I'll have not B, and then I'll have not B, and I'll have not A, and I'll have not A and B. And that'll all of those new sentences that I'm constructing, those will all go into stage 3 of building my sentences. So you can see immediately how fast the number of sentences is going to grow. It ends up being already at the stage 3 really, really big. Okay, so why am I pointing this out? Well, the idea here is we have these stages of sentences where, the first stage is all the atomic ones. The second stage is all the sentences that have the first application of these rules 2 through 6. Stage 3, again, will just be further applications of the rules that I just showed you. And the idea is we can cover all of the possible sentences in SL, and we can line them all up just like this, right? So I can put them in a big list like this, all in order. So remember when we had, let me make this really big. Let's see if this works. Yeah. So if you recall in our dominoes, what we had was this big long series. And so you can imagine this list that I was just constructing as having all the having all the sentences of SL lined up in this way. And by doing this, that's what's going to allow us to use mathematical induction in SL, right? So we needed to think about having these sentences with these series so that we can use mathematical induction. Because one of the things we're actually going to use, and you'll notice this when we go over the next example, is you're going to have claims that say, look, I'm going to assume that P and Q have some particular property already, right? And the example that they give in the book is you assume that P has an even number of parentheses, and you assume that Q has an even number of parentheses. And now you want to say something about this whole sentence. So P and Q are some sentences in the series. You don't really know exactly where, but we're now showing that here's how to build a sentence as in the next part of the series by using the rule that we have here, disjunction, how to do this sort of, how to construct a disjunction in our language. We're now going to say something about this sentence here. In other words, you can think about K as applying, right? So if we had, remember in our inductive step we said, look, we have this some case K. We don't know where K is in the series, but you can think of P and Q as being sentences that are at the K stage of being built. And now we're going to say, given that these are at the K stage, I'm going to assume that they have an even number of parentheses, right? So that'll be my inductive hypothesis. And then I'm going to say K plus 1, which is this sentence up here, I'm going to show that this also has that property of having even number of parentheses, which in fact it actually does. But the only way that this will actually work is if I can actually imagine, or if I can actually put the sentences of SL into a series. And what I've just tried to show you is that in fact the sentences of SL do form that kind of series, given the way we construct them with this recursive definition of the sentences. So now that we have this notion of a series, we can go on to talk about mathematical induction, or how we might use mathematical induction on a series of sentences of SL. And we'll do that in the next video lesson.